Today we're covering SPI. SPI stands for Serial Peripheral Interface. It's a serial bus communication where a master can communicate with multiple slaves at a time, or not really exactly at the same time. It needs to select one slave to have communication with it, and then it can select another slave to have communication with it. This one is used for a fast transmission. I've seen it with SD cards to save data. I use it for cameras to transmit images. Some touchscreens, I've seen it in some touchscreens and regular screens. And it's not really common, but also a few sensors uses SPI for communication. So how it works? Well, it's pretty simple. It's a bus that has 4 lines. The first one is source clock that will oscillate to transmit the data. The next one is master out slave in. That's the line that the master will use to transmit data outside and send it to a slave. So master out slave in means that it's data that's going from the master to the slave. Then master in slave out, it's data that it's being sent by the slave device to the master. And a slave selection, it's a wire that will be used to select the device, the slave device, to which one the master wants to communicate. So you can see here that we have these wires that are connected to different pins in the master. So the master will send a 0 to whatever slave he wants to communicate with, and that will initialize the communication. In your Arduino, your source clock, it's pin 13. MISO master in slave out, it's pin 12. Master out slave in, it's pin 11. And your slave selection is your pin 10. But if you need more slaves, you can use all the other digital pins. So you can use 9, 8, 7, 6, 5, 4, and whatever. As many as you need in case you have more than one SPI slave device connected. Here's an example of a data transmission between the master and slave. So as you can see, first the slave device goes to 0. Let's say this master wants to communicate with this slave device. So first it's gonna send a 0 here. This one and this one will remain at level 1, just as this one will remain at 0. It goes to 0, then the clock starts to oscillate, going between 0, 1, 0, 1, 0, 1, low, high, low, high. And with those 8 pulses that will be done by the clock, there's gonna be a data bit at every clock pulse. So in this case, the master is transmitting a 11001010 to the slave. So through the MOSI line with the clock oscillation and the slave select at low level, there's data that it's being transmitted from the master to the slave. After the 8 bits have been transmitted, the clock stops oscillating for a while. Then it oscillates again, but now the master is not transmitting anything, because now it's the opportunity for the slave to answer or transmit data to the master. So it's just sending 0, 1, 1, 0, 0, 0, 1, 0. And that data is in the MISO. That means that it's going for the slave to the master through the blue line here. Once all the data has been transmitted, or the 8 bits of data have been transmitted, the clock stops oscillating and all the lines stay at level 1. And since the master does not want to communicate anymore with the slave, it will go back to level 1 to stop communication or data transmission between master and slave. The way that we code it, it's really simple. If you're using a master device, it's a little bit more complicated if you want to have your Arduino in slave mode. First of all, we need to include the SPI library, which is given by Arduino, so you only have to include it. You don't have to install anything for this. And if you want to have your device in SPI mode, just type SPI begin, SPI transfer, and that's it in the master mode. In the slave mode, it's a little bit more complicated. You need to do pin mode and select the MISO, which is the slave pin 10, as an output. And then you have to use the SPCR function to enable your interrupt. And you need to attach your interrupt. So that's what these 3 lines, you need to write them in the setup mode, in your setup loop, in your function, in your Arduino code. And then you need to write an interrupt. An interrupt, it's a piece of code where the Arduino will jump when there's a physical interruption. In this case, the physical interruption will be when we receive data. So this is a piece of code that needs to be written, and the Arduino will jump here when we get anything through SPI because it's in the slave mode. That data is saved into SPDR, but we're transferring to RX, which is a global variable that's written to save that data, and then we can play with whatever we received in the loop. This is all the theory that we need to understand to move on. This is going to be explained more in detail in your lab 5 examples 3 and 4, where we're going to actually code one Arduino in master mode, another one in slave mode, and we're going to transmit data. So we're going to transmit between master and slave. But for all the details about, or the lecture about how SPI works, this is all that we need. Thank you so much.